Okay, so that's basically using some given information. The next section, we're just going to be expanding the expression. So this time maybe we have variables involved, or we're not given any information. We just want to kind of break things out or break them apart. And so if I have log of 10x, how might I break that apart? Well, if you notice, it's 10 times x. And so I could split this into two parts, because I can say, okay, I've got a log of 10 plus log of x. Because the 10 is being multiplied by the x, I'm using the product property to split it apart. Why is that helpful? Well, there's going to be times where this is helpful, like in this case, log base 10 of 10 is just 1. And so that might be a nice thing to use, okay, someday. So right now we're just leaving it like this, but I'm just answering the question that might be in your head. Well, why would we ever want to break this apart? Okay, okay, number 6. Now this is where the order that you do things does tend to matter sometimes. In this case, that 6 is not an exponent on the 2. The 6 is only an exponent on the x. And so you could not take and use the power property in this question yet, because the 6 is not a power on both numbers here in the logarithm. Okay. But what we can do is split this apart. Who thinks they would know how to split that logarithm apart? What do you think, Shannon? Good. So inside our logarithm when we started was a 2 multiplied by an x to the 6th. So because these were multiplied, I can split the log into natural log of 2 plus natural log of x to the 6th. Why is that helpful? Well, now I have a log with x to the 6th. So I have an exponent in here, and we can use the power property. So first of all, what Shannon did was the product property. And then now we can use the power property to say that this is natural log of 2 plus 6 times natural log of x. In this case, it doesn't really get us anywhere, but the point is we're just kind of practicing these properties. Jacob, what do you think about the next one? How could I rewrite that in expanded form? Not sure? You want to take a guess? Not really? Okay, if we see division, what do we do instead? Subtract. So it's log base 3 of the numerator minus log base 3 of the denominator. And then this one actually is going to get kind of long, because doesn't this second part look a lot like the one we just did? We have a coefficient and a variable. We have to split those apart first before we can do anything else. And so how would I split this? Oh, yes, Cody, do you have a question? No, because these are functions. Are you thinking like factor it out or something? Mm-mm. Well, that's kind of what, when you combine it, that you sort of, it looks like you're doing. But no, you can't factor out, because log base 3 is not multiplied by these numbers. This is a function with an input. And it's going to be the same thing when we start to learn about trig functions. You can't think about them as like variables being multiplied there. This is like a whole function. It's a new thing. That's why we're learning it. But what can I do with this 3y to the third? Well, it's multiplied here. So split it apart again. So we have log base 3 of x to the 4th minus log base 3 of 3 plus, oops, I should put parentheses here, plus log base 3 of y to the 3rd. Does everybody know why I did that? This is where, can I get some head nods or something like, yes, you know what I did, or no, you don't have an idea of what I did. A thumb up, or medium, or down. We can get some mediums, that's fine. Okay. So, for those of you with mediums, this log base 3 of 3y, this is 3 times y to the 3rd. So we have a number multiplied inside the logarithm. So I'm using the product property to split it apart. So log base 3 of 3, and then log base 3 of the y to the third part. Okay? And then the reason I put this in parentheses is because when I'm subtracting a logarithm, I wouldn't necessarily need the parentheses because it's just one logarithm. But, because it's like one value. But as soon as I'm subtracting two different logarithms, you do want to be careful that this is actually subtracting the first one and subtracting the second one. And so using that parentheses is important. Now, at this point, if I wanted to distribute that negative in, I could. And I'm going to do that as I do the next step. As I see, I've got some exponents here that can come out as the power property 4 times log base 3 of x minus log base 3 of 3, which is really just 1. And then I'm going to distribute this negative in minus and do the power property at the same time. 3 times log base 3 of y. That would be fully expanded form for that question. So the idea is you don't, when you're expanding, you don't want to see any more exponents inside of your logarithmic functions because you want to use the power property to get them out. You don't want to see any division. You don't want to see any multiplication or factors that can be split apart. And then you'll know that you're basically done. Look, I've got an x. Can't split that apart any further. I have a 3. The only factors of 3 are 1 and 3, so I can't split that apart anymore. The y, I can't split that apart anymore because it's just a variable. Back here, 2, where am I? Where's my fingers? There we go. This 2, I can't split that apart anymore because the only factors are 1 and 2. X. Now this one, log base, there we go. Log of 10. Technically, I could keep going with that. 5 times 2, or, 5 times 2 is 10. But I don't want to do that because my base is 10. Log base 10 of 10 is a very easy number to evaluate. So you really want to, when you're expanding out as far as you can in a helpful way. So you wouldn't want to go farther with this one because it wouldn't be helpful. Log base 10 of 2 is not as easy as log base 10 of 10. All right, the next section is just doing the opposite. How would I condense these expressions? So Keegan, looking at number 9, take a guess. How could I rewrite this as a single logarithm? Log base 2 of, that's what everybody says, but that's not right because follow the properties. If logs are added, the numbers are actually multiplied. And so I'll show the work, but you wouldn't necessarily have to. 3 times 8, right? And then log base 2 of 24 would be the correct answer. Does that make sense? Gary?
So you need to put 24 all here if you left it at 3 times 8.
Oh, that'd be fine. If you left, I would simplify it to 24. Yes. So the question was, could you leave it as 3 times 8, but simplify if you can. So what about the next one? Yeah, be careful though. It's not dividing first because look at this logarithm has a 2 out front. So before you can condense using the division property, you have to use the power property, which says if there's a number out front, it becomes the exponent. So we're thinking backwards from what we just did. Numbers that were exponents became the number multiplied out front. If there's a number multiplied out front, it becomes the exponent. So the first thing I'm going to do is rewrite this as log base 5 of 4 minus log base 5 of 5 squared, which, what is 5 squared? You say 25. And so now when I use the quotient property like Lane wanted to do, and I write this as log base 5 of 4 divided by 5 squared, instead of writing 5 squared, I'm going to write the 25. And sometimes I put parentheses around those numbers to show that it is inside of my logarithmic function. Right, number 11, they try to screw you up by throwing in natural log because most students don't like it because it doesn't have the base showing and it's like a shortcut way to write things. But it works the same way. We have a 3 out front of our natural log, so that becomes an exponent. This one doesn't have anything out front. And so we can rewrite this with the power property as natural log of 6x all to the third. So really the 6 is to the third and the x is to the third. If I wanted to simplify this, I would say 6 to the third is 216. Let me double check that. Yep. So this is natural log of 216x to the third plus natural log of 4y. Can I condense it further? And if so, how? Macy, what do you think? Okay. You can, because natural log and natural log have the same base. They're both base e, and when we're adding two logarithms with the same base, we can use the product property. So in this case, we would make this one single natural log of multiply these two numbers together. And so I'll show, I'm just going to write multiply, and then I'm going to do the math. So 216 times 4 is 864, and then x to the third y. So there's our condensed logarithm. Does that make sense, Macy? Okay. And we're going to stop there for today, but what I would like to tell you, if you want to get started on it, is just what your homework is going to be, so that if you want to get started on some of these first questions, then you'll have less homework tomorrow. It won't be as overwhelming. So 6.5. I'm not going to check it tomorrow, though, so it's totally up to you, but page it's on the back of this one, I think. 3. And I might add a few. I did a lot of odds because I wasn't sure if we would have time to start the lesson early. Oh, blurry. There we go. It's all odds. I might add a few evens in tomorrow, but this at least is a place for you to get started. When you're doing the problems and you get to a point where you're like, I don't think we learned this one yet, just stop there. That's probably where we haven't gotten to yet.